Hi. Okay, so since the last video, I realized that my code hasn't been running as efficiently as I've been wanting it to, since it's been running in pure Python. And I knew that if I made a switch to something compiled, something simpler for the computer to run, it would run faster. But like, I didn't want to have to switch entirely to another language like C++ or even C for that matter. But I did find a compromise. I did find something that I think would run better than if I were to take my code and process it through Numba, which is Cython, compiling with Cython. And I did find some improvement. I'm gonna test this out real quick. Let's do. We're gonna do the updates for the particles, uh, using just a regular range. For loop in a range. I'll run it again in a second with p range, which is supposed to parallelize everything. And we'll actually see the effect of that in the graphs here. All of the CPUs will light up all the way, and hopefully we'll get a speed increase from that. In this case, it's just going to do a few thousand updates, and then just find the difference between those times. And yeah, let's actually get rid of nanosecond stuff. I don't think we're going to need that. Okay. Let's go ahead and compile. Okay. That should have appeared here. Let's give it a sec. Come on. There it is. Okay. Now if I run this, so it's running a few hundred updates now every second, and you can see that the maximum CPU usage is only at like 25-30%. It's not really taking advantage of the cores. Yeah, okay. So there's our time. On average, we got, it looks like 3.5 thousandths of a second, roughly. Yeah, tenths, hundreds, thousandths, 3.5. 3.5 thousandths. Let's see here. So we're doing 1,000,000 particles at the moment. I'm gonna go ahead and get rid of this build and update this to use p range. So we need to disable the global interpreter lock. No, GIL equals true. Schedule static, I guess. Is that what I want to do? Static? Probably. Yeah. Anyway, yeah, let's go ahead and recompile. And see what happens when I run it again. This time you can see that the CPU is being maxed out. The weird thing though is that despite parallelizing everything, I actually don't know if that static portion did anything. It didn't seem to make a difference from the last time I tried this, but the difference is not huge per update. I mean, there is a difference. It's just not as big as I thought it would be, considering I have 8 well, I mean, I guess I've got 8 cores, but I think technically I've got 16 because there's different types of cores. But anyway, yeah, no, this wasn't what I was expecting. It was a speed increase, but it wasn't nearly as much as I thought. Again, this is with 1,000,000 particles, so I I don't know. Maybe it'll work better with a much greater number of particles. I suppose I could test that really quick to see what kind of difference that would make. Yeah, let's see. Let's get rid of that, and instead of 5,000, or yeah, instead of 5,000, we'll do 500. Yeah, I'll just increase it by an order of magnitude of particles. I'll just do 10 million. See what that does. Yeah. Okay. Oh wait, yeah, we gotta, I got a text. Thank you, they said. Okay, anyway. Yeah, I gotta switch this back to using just range. There we go, and then compile. Okay, and then if I run the test, it's gonna take 10 times as long. There we go. Unsurprisingly, it's very similar to what we were expecting. It's about 10 times the update time that we had last time. Although, I am seeing that the bit after the half is a little different. Anyway, this is not parallelized yet. So if I were to do that, I wonder what kind of difference that would make. Okay. One thing I think that's pretty neat, at least I think this is what's happening, is that the operating system seems to be taking a single thread process and running it across all of the all of the cores, just switching between them, so that they all contribute the same amount, and they don't burn out. I guess I think it's to prevent them from literally from dying, from burning out. I don't really know though. Hey, there we go. That actually did make a difference. A notable difference, although not nearly as much as I thought. Again, I thought it would be greater than that. Oh well. It's still good news. This is still good news. The numbers I'm getting here are similar to those that I was seeing in my code when I was using Numba. So I don't want to necessarily switch back to Numba. I do like cython syntax actually. Having to set things up this way kind of sucks, but that's okay. So I guess this is where I'm gonna go from here. Anyway, thanks for watching. Bye.